In this video, we're going to walk through the Microsoft Lab about enhancing service availability and data locality using Azure Traffic Manager. Now, Azure Traffic Manager is an amazing service that allows you to have web services balanced throughout the world so that the end users will eventually go to the closest resource, and only the closest resource, unless there's an outage in a specific region, in which case then they will go to a resource that is further away, only because of availability concerns. So let's go ahead and take a look into this. If I go into, yes, Unit 1, okay. It talks a little bit about a scenario here. In this case, you are a global music streaming application, and you want to make sure customers experience near zero downtime, and it needs to be responsive. Therefore, you want to have both resources that are close to the end user to be responsive, as well as redundant resources in case there's an outage in a specific region. And so Azure Traffic Manager, in this case, is going to be the best answer. Here we walk through a basic environment of it. In this scenario, if we have our music streaming application, maybe we have 3 different web servers set up, or 3 different groups of web servers in 3 different Azure regions. We can see here we have one in the US, here we have one in Europe, and then here we have one in Asia. Everybody who's in the Americas, either North or South America, should go directly to the US location. Everybody who's over in Europe or in Africa should go to the European location, and then all of Asia should go to the Asian location. So we should be able to help direct people to the closest resources available whenever they're available, whenever they can. However, if a region goes down, those people should be redirected to a different location. Not quite as fast, not quite as responsive, but available nonetheless. So Traffic Manager talks about how it does this, and it actually works using DNS. Basically what happens is there is a DNS server in Microsoft. So a DNS server pops up and people request access to your website from DNS. They say, hey, where is this DNS server? Or I'm sorry, where is this web server? And the DNS server looks at the source IP, or looks at where the client is coming from. In this case, it says, oh, I see you're coming from Greenland. Therefore, I want to send you to Europe. So there's rules in the DNS server that says if an IP address who's in Greenland shows up, send them to this location. Same thing for Africa. Somebody from Africa hits their DNS server and says, hey, where is this web server? The DNS server says, oh, well, you are in Africa, therefore I'm going to send you to Europe. However, if somebody in the Americas hits the DNS server looks at its rules and says, oh, you actually want to go over here to the American web server because that's the closest location for you. So DNS helps play a great role in this environment. The DNS server also has some intelligence to where if one of those sites goes offline, it can then redirect to another location. There are different ways that it can handle this routing. First off, there's a way called weighted routing, which is very basic. Basically just you identify priorities of one site over another. As you can see there, for instance, region A has a weight of 50, region B has a weight of 50. Therefore, they would essentially have a 50-50 weighting, or you would go to one or the other. And then if it goes offline, for instance, in this case, if region A goes offline, then the balance or the weighting is rebalanced, and region B suddenly becomes much more popular. So that's weighted routing. There's performance routing, where Traffic Manager can actually look at the performance of the websites and balance traffic accordingly. And then there is geographic routing, which is what I described up above, of saying this region goes to this website, that region goes to that website. And then multi-value, you can actually use multiple ideas with regards to this routing. All right, well, let's go ahead and get started. I'm going to go ahead and load up a sandbox here. This will take a couple of minutes, but in this scenario, again, we are still talking about that music streaming application. We have users in the US, Asia, and Europe. So we want to fail over, oh, it looks like in this case, just US to Asia. We want to create a traffic manager profile. All right, let's see, once my sandbox is available, great. So these Azure CLI commands, I always like to read these backwards. We're going to create a profile. What type of profile? Well, a traffic manager profile in the Azure networking. We're going to put this in a resource group because this is a lab environment provided to me from Microsoft. That resource group is already defined. I may specifically create a separate resource group for this if I was doing this in production. What do we want to call our traffic manager profile? Well, we're going to call it TM Music Stream Priority. There will be a routing method, in this case of priority. Kind of a nice naming scheme to say that that's priority. We want a unique DNS name. In this case, it's going to be TM Music Stream Priority with some random numbers at the end. Let's go ahead and copy and paste that and let that go. So that will create a traffic manager profile. There isn't currently any destinations for it, but we did just create it with a name of TM Music Stream Priority. And I'm looking for, oh, okay. Looks like we're then going to jump into this. Yeah, okay. I'll go ahead and copy and paste this because this will actually take a couple of minutes. So in this case, we're actually deploying a full package of resources in Azure. In this case, let's actually go to this JSON file right here and open this up. What this JSON file is actually a full deployment in Azure. This is basically telling us, yeah, we're going to go ahead and we're going to create some VNets, some virtual networks, in this case in East Asia. We're also going to create VNets in West US. We're also going to create VNets, oh, just the two. Okay, so we're creating the two VNets. We're creating some network cards to go along with those. And we're also going to be creating some virtual machines. Because of all of this is being combined into one process, that's going to take a couple of minutes, so we have time to walk through this. Let's see, so then we have the resources. Yep, so we're going to create some security rules with our network security groups, allowing port 80 to come through. Same network security group, port 80, this time for the West US instead of Asia. Configuring our virtual networks. Configuring the public IP addresses for both Asia and the US. Configuring the network cards. In this case, we are assigning static IP addresses to our machines, 10104, and then in the other location, I assume 10104 as well. Oh, 10204. That makes more sense. A little bit more about the virtual machines. These are going to be standard DS1 v2s. Running Ubuntu 1804. All right. So all of that is running in the background, and we will let it finish before we continue on. All right, well, hey, that took significantly less time than I expected. However, now if we look into the Azure portal, under all resources, we should be able to find our two virtual machines. There's one in East Asia. If I keep scrolling, I will find another virtual machine in here somewhere. There we go, another virtual machine in West US. We see, yes, they have virtual networks, they have public IPs as we expected, and in here is our traffic manager profile, specifically stated for priority. All right, so we created the virtual machines, we created the traffic manager. Now we need to add the endpoints or those virtual machines into traffic manager. So the Azure CLI right here, what we're going to do first off is we're going to get the IP address for the West US VM. If we look through this, this is actually a command that then saves as a variable. So the command we're doing is show public IP in the network of Azure. This resource group, we're specifically looking for this name, this virtual machine name. We're querying specifically for the IP ID, and we're looking for a TSV as an output. If I run just that, then we'll go ahead and we'll see, oh, well, here's the output that it's giving me specifically for the ID of that device. I want to save that as a variable called West ID. So then I can copy that. And putting that as a variable means I can then type just simply echo $ West ID, and it spits out that same ID over and over. Makes it a little bit easier for me to manage in the future. Next thing we want to do is we want to create an endpoint in Traffic Manager, or essentially add a point to be managed. Again, the resource group, the profile that we created for priority, we're going to call this endpoint primary West US. Specific type being an Azure endpoint with a priority of 1. Remember, we can set multiple priorities here. So we're going to set priority of 1. And then which ID or which resource am I putting in? I'm going to put in that West ID. Before I continue on, let's look at, we've got the same thing here for the East ID, which looks at the East Asia VM, gets its ID, and then the East Asia Traffic Manager endpoint. I'm just going to copy all of that and paste it all in. All right, with that being done, we can now do a list of endpoints for our traffic manager. So I'll go ahead and copy and paste. And we'll see the list of endpoints. There will be 2, one in the primary West US and one in the failover East Asia. If I look back into the Azure portal, there they are, my primary endpoints, primary West and then failover East Asia. All right, so now we should be able to look at DNS. What we're going to do is we're going to do a couple of retrieving of IP addresses. So NSLOOKUP will help find a name or an IP address for us, specifically looking against an IP address for the West US 2 NIC. And then same thing for the East Asia NIC. And then lastly for Traffic Manager. So let's go ahead and run those and see what that looks like. So we should get 3 IP addresses back. And if I scroll up, we'll see the very first NSLOOKUP command. It returned back an IP address 168.63.129.16. So that is my West US machine. Nope, sorry, that's the DNS server that responded to it. That is my West US machine. The East Asia is 137.116.163.81. And then lastly, the traffic manager is this guy right here. Now I can actually go slightly off the script here. Let's browse to that West US. And we'll see, yes, okay, welcome to Music Stream. That's the name of my application, and says this is the West US region. If I then do the same thing for East Asia, go to, we'll see, yeah, hey, here's the East Asian region. And then if I go to the traffic manager, which I believe I need to be this. Then it defaults to the West US region. So Yeah. All right, so it tells me, yeah, go to the traffic manager's FQDN, and it is routed to the endpoint that has the highest priority. In this case, the highest priority was, well, the primary location of West US. If you didn't quite catch that, we can go ahead and paste this in, and it will spit out more specifically the URL in HTTP format. All right, so we confirmed that it worked. Now we want to disable that endpoint. We want to show if something breaks, that our endpoint will keep working. So we have 3 endpoints here. First off, we have the traffic manager, and we see TM music stream priority. We then have East Asia and West US. End users aren't going to be hitting the East Asia or West US URLs. What they're going to be hitting is they're going to be hitting this traffic manager URL. And so we want to make sure that whenever they hit that traffic manager URL, they're going to whichever the priority system is. In this situation, we're going to update the endpoint, specifically the primary US, and we're going to disable the endpoint. So once we disable the West US, Traffic Manager should continue, but it's going to continue and send me to a different location. So now when I refresh my page, it should now say I'm in Asia. There we go. So Traffic Manager moved me from one side of the world to the other side of the world simply because a machine went offline. All right. So that was one type of routing. We then talk about optimizing with performance routing. In this case, performance routing, we are looking at the performance of the servers throughout the environment. And then exercise. All right. So here we're going to create another traffic manager profile. Again, this time using performance routing instead of priority routing. So create profile traffic manager in networking of Azure. In this case, the routing method is performance. I'll go ahead and copy that and paste it on in. As always, while that's running, we can then look back at our all resources, and we'll see that these devices or these resources are showing up. I can find the traffic manager. There's the priority traffic manager. I may need to refresh this before I see the new traffic manager. It did create. Performance. There we go, performance. All right, so in this case, we created a performance profile. Now we can create the 2 endpoints and add them into that. This is exactly the same as what we saw before, except this time, instead of adding the endpoint to the priority, we're adding it to the performance. So go ahead and copy and paste that in. And then we can test it. So this command right here will actually get us the output of the traffic manager URL. Let me close my other tabs here briefly. And it tells me, yep, right there is my traffic manager. Great. So it opened up in a new tab, defaulted me to the West US region. That was just the most performant region in my area. Therefore, it sent me right there. If people were to start hitting this website over and over, then the most performant region would stop being the West US 2 and would eventually become East Asia. I'm trying to slow it down here by refreshing, but it's just not doing it to me. I could, in theory, log into this virtual machine and have it start running some different disk tasks or different memory tasks in order to slow it down, and then we would see failover to the East Asia region. So that was only 2 types of our traffic manager. If we look back at our discussions earlier about the various types of traffic manager, There was weighted routing, which we didn't talk about, or we didn't show the example of. The idea is that you are routing between all of those devices there according to weight. The higher the weight, the more likely they are to be hit. In this case, we had an example of 50, 50, and 5, which means out of 105 requests, or more specifically users, then that means 50 would hit that one, 50 users would hit that server, 50 users would hit that server, and then 5 users would hit that server. So that's weighted routing. There's performance routing, which we just saw an example of, but we didn't actually get to fail over because our servers weren't slowing down. But we can see, yeah, it kind of looks at DNS resolution and DNS ping times to be able to see which server is going to be the quickest to respond. And then geographic routing, which we didn't get an example of, but is almost exactly the same to set up. You set up your endpoints. Oops. As we can see right here, yeah, you set up your endpoints, you define them to a region, and then in Traffic Manager, you have to specify which endpoint goes, or which source goes to which endpoint. All right, so I think that was optimizing. Yep. And there we go. There's the summary. So Traffic Manager, it's a very, very fun DNS capability. Allows us to send people all around the world, all depending on availability and performance of our resources.